Have you ever wondered how AI can write a poem or explain a complex scientific theory? The answer often lies with a large language model, or LLM. Simply put, an LLM is a very large artificial intelligence program that has been trained to understand and generate human-like text. It is not sentient or alive, but rather a sophisticated tool for processing language. It learns from an immense volume of text data, allowing it to recognize patterns, context, and nuance. This video is your clear ladder from basic concepts to expert-level understanding. Imagine Lego. A simple program follows a short manual, while an LLM is like a master builder who has studied every manual ever made. The master builder doesn't just copy, it understands how bricks connect and can invent new creations or write a manual from your description. That's the power of an LLM, generative creation from deep patterns learned across vast information. No CS or advanced math background required. We'll go step by step. First, what an LLM does day to day, then the components that let it function. Finally, advanced techniques, limitations, and safety. By the end, you'll grasp what an LLM is, how it works, what its limits are, and how to continue your learning journey. Okay, so let's begin. At its most fundamental level, a large language model is a sophisticated pattern matching system. Plainly, an LLM learns to predict the next word in a sequence by training on enormous collections of text and code. It isn't taught grammar explicitly. It observes billions of sentences across books, articles, websites, and more. It absorbs statistical relationships between words and phrases. Consider, the sky is most often blue, sometimes gray or dark. The model learns these probabilities at massive scale. Blue is high probability, table is extremely low. Training shows text, asks what comes next, and strengthens helpful internal connections while adjusting unhelpful ones, billions of times. When you ask a question, it starts a high-speed game of what comes next, assembling the answer one token at a time. The capital of France is Paris. It's kind of like autocomplete on steroids. It's not learning facts like a human, it's learning statistical likelihoods that produce coherent, relevant text from your prompt. First, an LLM doesn't see words as we do. It breaks text into smaller pieces called tokens. A token can be a whole word like apple, or parts like UN, friend, and li. Like a chef with core ingredients, tokenization lets models handle vast vocabularies, including new words. Next, parameters, the model's internal knobs. Large models have billions, adjusted during training. Each parameter holds a tiny piece of learned information, representing connection strengths between tokens. More parameters generally store more intricate patterns, style, and nuance. Data is the food the model consumes to learn, a massive corpus from the public internet, digital books, scientific papers, and other sources. Quality and diversity matter. If data contains biases, inaccuracies, or harmful content, the model can absorb them. A prompt is tokenized, processed through billions of parameters to score next tokens. Then the model selects one and loops, building the response token by token. All right, that's the basic mechanics beneath the surface. Tokens, parameters, and data working together to predict what comes next. The expert's lens, fine-tuning, safety, and real-world limits. After broad training, a model can be specialized via fine-tuning on a smaller, curated, high-quality dataset. To build a legal assistant, you'd fine-tune on legal documents, case law, and scholarly articles to adopt domain vocabulary, tone, and formatting. Outputs become more accurate and useful for that purpose. But LLMs have limits. They can hallucinate, produce fluent yet incorrect or nonsensical content. They're pattern engines, not knowledge databases, so they may invent facts or sources. Models can absorb societal biases from training data, leading to unfair or offensive outputs. Engineers add guardrails, filtering prompts and outputs, and use reinforcement learning from human feedback to prefer helpful and harmless answers. Training state-of-the-art models demands enormous compute, energy, and money, often millions of dollars. This concentrates development among well-resourced organizations and raises questions about access, competition, and democratization. From user to informed practitioner, we learned an LLM predicts sequential text from vast datasets, acting like a knowledgeable assistant based on learned patterns. It's a sophisticated pattern generator, not a thinking entity. We covered tokens, parameters, and data, and how dataset quality shapes capabilities and flaws. Advanced topics, fine-tuning power, safety guardrails for hallucinations and bias, and high computational costs. An informed user pairs curiosity with skepticism, oversight, and ethics across medicine, law, education, and beyond. Use a public LLM tool, experiment with prompts, be specific, request tone, add context. Notice how small changes shift outputs, celebrate good answers, treat mistakes as hallucination demos. This mindful experimentation builds real intuition about both the power and the pitfalls of LLMs. Yeah, go try it, and, stay curious and cautious. Subscribe us for your AI journey. Humanize AI.